For decades, astronomers have been exploring objects beyond our own solar system, and just when it seemed that all hope was lost, surprising events happened. This was the situation in which these astronomers found themselves after years of unsuccessful searching. Something unexpected happened. Two objects appeared simultaneously. Scientists and astronomers from all over the world, including those from SETI and NASA, became involved in the investigation of these mysterious visitors. What could they learn from them? Where did they come from, and what can we expect the arrival of the next one? The first object to emerge from the vacuum of space was barely visible from an observatory telescope. It was determined to have originated from Vega, an alien star 147 trillion miles away, and was traveling through space at a speed of 57,000 miles per hour. It had an elongated cigar-shaped and was 1,000 meters long, a dimension that is not typically large for a comet or asteroid. There is speculation that it may have formed in a spacecraft-like disk and, as it passed close to our Sun, it made a sharp turn and accelerated in another direction. The behavior and motion of these objects are highly unusual for asteroids or comets. Just as astronomers were beginning to recover from the shock and confusion caused by the arrival of the first unexpected visitor, another event occurred. Another one appeared. Gennady Borisov, an amateur engineer and amateur astronomer, observed a moving object in the pre-dawn sky from his personal observatory in Crimea. Using a telescope he built himself, he was able to immediately notice the uniqueness of this object. It was moving in a direction opposite to that of comets, normally found in the main asteroid belt surrounding the Sun. The question arises whether these interstellar visitors have a natural origin or are artificial in nature. To answer this, it will be necessary to travel to their location for further investigation. The first interstellar traveler came from the Vega star system and was named Hawaii, meaning explorer. Vega, also known as the future North Star, is a bright star located only 25 light years from Earth, visible in the northern hemisphere summer sky. Due to the wobble of the Earth's axis over a period of 26,000 years, our perception of the North Pole gradually shifts to different stars. Vega was a pole star many millennia ago and will return to that position in approximately 12,000 years. In early 2013, astronomers discovered an asteroid belt around Vega, suggesting the possible presence of extraterrestrial planets. Among the rocks found in this belt, one in particular stood out, the so-called Oumuamua. NASA had only 11 days to observe this object, which moved at a speed 3 times faster than the Earth's orbit around the Sun. After that brief period, it was no longer detectable because it was too small and faint to be seen. This object entered our solar system and, after passing close to the Earth, abruptly accelerated out of our solar system in a different direction. As we followed Oumuamua's trajectory, we expected its orbit to be hyperbolic, with only the gravitational force acting on it. However, this was not the case, as it seemed to experience additional acceleration, as if something else was exerting pressure in addition to gravity. By the time it was spotted, this cigar-shaped object had already passed close to our Sun, making a sharp turn and beginning to accelerate in a different direction. Scientists were especially intrigued by two aspects: the mysterious acceleration away from the Sun and its peculiar shape. In the years that followed, scientific publications and the media were full of speculation, despite NASA's effort to classify it as an asteroid and then as a comet. However, it remained unclear exactly what it was. Avi Loeb, a Harvard astronomer, suggested that it might be an artificial structure created by an intelligence. Finally, someone had the courage to state what everyone was thinking, as it challenged our understanding of physics and perplexed everyone. After reaching its closest point to the Sun, the object began to leave our solar system at an extraordinary speed, ensuring escape from the gravity of our solar star. This behavior, more typical of a comet, was unusually smooth and steady for such a fast object, making it highly unlikely that it was a rough and irregular comet in the process of outgassing. On October 7, 2017, the object was heading towards the constellation Pegasus on a route to an unknown destination. With the technology available at the time, it was impossible to capture an image of Oumuamua in close proximity, so hand-collected data are all we have. However, all the peculiar characteristics of this object suggest a plausible possibility. It could be an extraterrestrial craft equipped with a light sail. In fact, an artificial origin would clearly explain these peculiarities. Initially classified as a comet, the object reclassified as an asteroid after observations failed to reveal a fuzzy coma. The discovery of Oumuamua was an anomaly, as our solar system does not produce debris like this. Using the James Webb Telescope in West Virginia and the Allen Telescope in Northern California, astronomers have been listening for any potential signals, but the object has remained silent until now. On the other hand, Borisov turned out to be significantly easy to understand than its cosmic companion. It has been confirmed as the first interstellar comet composed of a mixture of water, dust, and carbon dioxide, similar to that found in the periphery of the solar system. It had a visible tail and matched what scientists had predicted. However, Borisov 1, the enigma seems even stranger. It is believed to have originated in an ancient solar system revolving around a red dwarf star, the faintest and most common type of star in our galaxy. Based on its speed and trajectory, an international team has hypothesized that it may have originated near the white dwarf Ross 573, located about 629 trillion kilometers from the Sun. Their theory is that it was ejected into space about 900,000 years ago, following the violent collision of three large objects in the celestial neighborhood. Some speculate that if they were extraterrestrials, they might be spying on us with advanced spacecraft capable of hiding in plain sight. But who can say for sure? The discovery of the James Webb Space Telescope has shaken the foundations of our cosmic understanding, challenging established rules and revealing hidden mysteries of the cosmos. This unprecedented breakthrough has generated palpable anticipation in the scientific community, as each observation provides new insights into the universe and its deepest secrets. The massive object recently detected by the JWST raises questions about the origin of the universe, and its identity remains a fascinating enigma. This discovery revolutionizes our perception of the cosmos and invites us to explore new horizons of understanding. Join us as the James Webb Space Telescope takes us on a journey through time, revealing cosmic secrets that defied our imagination. On December 25, 2021, humanity took a leap forward in space exploration with the launch of the James Webb Space Telescope, the JWST. This cutting-edge instrument in cosmology and infrared astronomy has opened up new possibilities for studying distant stars and galaxies, providing exceptional resolution and sensitivity. One of the JWST's most outstanding achievements is its ability to observe the cosmic past, allowing us to study the first stars and galaxies, as well as to accurately analyze the atmospheres of exoplanets and the enigmas of black holes. These cosmic phenomena, formed by the gravitational collapse of stars, represent areas where the laws of space and time are extremely distorted, challenging our fundamental understanding of the universe. The event horizon, known as the point of no return, is a region that challenges the fundamental principles of modern physics. Although black holes are relatively recent discoveries, the theory of relativity had suggested their existence for long before they were directly observed. This theory postulates that sufficiently dense masses can be bent space-time, giving rise to strange structures that we call black holes. The reality of black holes, initially invisible, becomes evident thanks to their gravitational effect on the surrounding environment, including space satellites and nearby materials. Scientists use a variety of sophisticated instruments to detect evidence for the existence of a black hole. They observe how nearby stars and their surrounding gas are affected, analyzing gravitational effects to determine whether they are orbiting the black hole or being ejected by its immense gravitational pull. The James Webb Space Telescope, equipped with advanced tools, allows us to probe deeper into the universe and tackle problems once thought to be indetectable, such as the nature of black holes and nearby stars. When objects approach a black hole, they radiate large amounts of energy, illuminating the galactic scene. However, despite their dramatic impact on their surroundings, black holes remain enigmatic as to their dimension, as their precise size remains undefined, as predicted by the theory of relativity. This is because the gravity of the black hole determines the fate of any object that comes too close, and the hairless theory further explains this mystery of black holes. The theory suggests that once a black hole reaches stability after its formation, it has only three measurable properties: mass, electric charge, and angular momentum. However, this apparent simplicity masks the inherent complexity of these cosmic phenomena, making it difficult to distinguish between black holes that may have similar physical characteristics. Examining the types of black holes reveals a diverse family of distinctive characteristics. The first type of stellar black hole, which is the smallest and has a mass between 1 and 100 times that of the Sun. On the other hand, there are supermassive black holes, which can weigh millions or billions of times the mass of the Sun. It is believed that the death of massive stars in the early universe gave rise to these supermassive black holes. In the middle range, there are intermediate black holes, which lie between stellar and supermassive black holes. Contrary to popular belief, some black holes can be relatively small, reaching the size of an atom. It is difficult to imagine that such massive stars could collapse to such a tiny size and at the same time maintain such a gigantic mass. However, the reality is that in the Milky Way and in the universe in general, there are a multitude of scattered black holes, each with a mass equivalent to millions of times that of the Sun. Theoretical and empirical observations have shown that the largest black holes tend to occupy a central position in galaxies, including our own Milky Way galaxy. At the center of the Milky Way resides Sagittarius A supermassive black hole with a colossal mass equivalent to about 4 million suns. This makes it the most massive object in its galactic environment. Ongoing research of black holes begs the question, what makes them so fascinating? The inherent complexity of these entities has kept scientists busy for decades. Black holes are truly cosmic laboratories that challenge numerous theories rooted in the general relativity and quantum mechanics. They also offer opportunity to explore unknown areas of physics, expanding our understanding of the fundamental principles of the universe. However, our understanding of black holes remains limited because we cannot observe them directly. Stellar mass black holes, for example, reach temperatures in the billions of Kelvin, which limits us to using indirect methods and theories to study them. At the heart of the intrigue surrounding black holes is the event horizon, a boundary in space-time from which light cannot escape. This fundamental feature not only denotes the gravitational power but also represents a domain of reality beyond our human comprehension. As we approach the event horizon, the laws of physics undergo profound change, but it still offers a window into the mysteries of these phenomena. While we understand how some black holes form as a result of the gravitational collapse of massive stars, the exact process remains a subject of study. Scientists point to the importance of high-density environments such as those within stars for this type of collapse in today's universe. However, during the early stages of the universe, the extreme densities of the Big Bang significantly increased the probability of black hole formation. In addition to high densities, black hole formation requires an uneven mass distribution to prevent mass from becoming uniform. In such dense environments, it is believed that there was initial fluctuation in density that allowed black holes to grow through gravity. Gravitational collapse is not only the way black holes can form, high-energy collisions can also create them if the density reaches sufficiently high levels. However, since 2002, no such event has been detected, either directly or indirectly, although hints of mass imbalances have been suggested in particle-accelerated equipment. What is fascinating about black holes goes beyond their formation. Their dynamic nature is intriguing. They have no defined sizes and can continue to grow without limit by absorbing surrounding matter, such as space gas and dust. This ability is responsible for the creation of supermassive black holes and has been posed as a pathway for the formation of intermediate black holes in globular clusters. Black holes can also merge with other objects, such as other stars or other black holes, to form gigantic black holes. Despite these complexities, black holes formation remains a subject of study, and with the operation of the James Webb Space Telescope, we are poised to discover more details. However, there have been concerns about the possibility of a black hole impacting Earth and destroying it. However, scientists have ruled out this possibility, demonstrating that a black hole of the same mass as the Earth would not suck it in, but would rotate around it due to its equivalent gravitational attraction. In addition, black holes do not move through space consuming celestial bodies, so the Earth would not succumb to a black hole due to its remoteness from our solar system. NASA's billion-dollar investment to create the most powerful telescope in history is serving its purpose by providing us with exciting new insights into the early stages of the universe and our own origins. Recently, researchers have discovered 6 mega-galaxies that formed in the early universe, when it was a hot, dense mixture. The James Webb Telescope has continued to explore and examine these discoveries, and each observation reveals even more distant and ancient galaxies, each with unique characteristics. However, the most striking discovery is the detection of organic material, including the building blocks of life, in one of these ancient and primitive galaxies. This represents a breakthrough that transforms our understanding of the cosmos. Join us as we explore this incredible discovery made by the James Webb Space Telescope and what it could mean for our future. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Astronomers using the James Webb Telescope have succeeded in detecting the most distant organic molecules known in the universe. This is the first time complex molecules have been found in the distant universe. These complex molecules were found in a galaxy called SPT 041847, located at a distance of more than 12 billion light-years. Given that the universe is approximately 13.7 billion light-years old, this galaxy is extremely old. The structure, which resembles a cosmic smoke ring, reveals the presence of complex organic molecules similar to smoke or smog. This discovery provides information about the chemical interactions that occurred in the earliest galaxies and their relationship to star formation. On Earth, these molecules, known as polycyclic aromatic hydrocarbons, are found in smoke, soot, smog, engine exhaust, and forest fires. Organic molecules are based on carbon, which is considered one of the building blocks of life, as it is an essential element in the amino acids that make up proteins. Light from this dusty galaxy began its journey across the cosmos when the universe was less than 1.5 billion years old, which is only 10% of its current age of 13.8 billion years. Using the James Webb Telescope infrared capabilities, which can detect light invisible to the human eye and penetrate cosmic dust, new details about the galaxy were captured. In addition, the Space Observatory benefits from a phenomenon known as gravitational lensing. This phenomenon occurs when two galaxies are almost perfectly aligned from our perspective on Earth. causing the light from the background galaxy to be deformed and magnified as if it passes near the foreground galaxy, forming a ring known as an Einstein ring. Gravitational lensing was originally predicted by Albert Einstein in his theory of relativity. Thanks to this increase in magnification, we can observe in detail the components of a galaxy in the early universe that we cannot otherwise see. During a thorough analysis of the data from the Webb telescope, astronomers detected the signature of organic molecules in an unexpected way. This surprising discovery is helping astronomers answer some of the most fundamental questions about the origin of the universe. It is amazing that scientists can identify molecules located billions of light years away that are similar to those we know here on Earth, but are often associated with undesirable forms such as smog or smoke. Since its launch, the James Webb Telescope has been in the news for its observation of miles of colossal galaxies. Now, the James Webb Telescope has made shocking new discoveries that could completely change our understanding and require a thorough overhaul of all of our cosmological theories. These groundbreaking discoveries could have a significant impact on our current knowledge. Continuing its series of discoveries questioning the Big Bang, the James Webb Space Telescope has found the most distant cluster of galaxies ever observed, at a distance of 30 billion light years. According to the researchers, this cluster is possibly one of the largest in the universe today. Although the 7 galaxies that make up the cluster had previously been observed with the Hubble Space Telescope, scientists did not have precise information about their distance or whether they were actually bound together as a group. Because of the time it takes light to travel from these distant objects to the position of the JWST telescope in orbit around the Sun, we are observing these galaxies as they were approximately 650 million years after the Big Bang. The present form in which we see the protocluster gives the impression of being small. However, if we could observe it instantaneously without the limitation of the speed of light, it would mostly likely appear colossal, capable of exerting a gravitational pull on thousands of galaxies. Simulations by researchers suggest that this protocluster could be one of the largest clusters in the universe today. Recently, the James Webb Telescope also made a surprising discovery when it found a tiny galaxy that existed 13 billion light years ago and has been developing stars at an exceptionally high rate relative to its tiny size. This is believed to be the smallest galaxy ever discovered at this distance, approximately 500 million years after the Big Bang. In a groundbreaking finding, a team of researchers from the University of Minnesota took the James Webb Telescope out to peer more than 13 billion years into the past and discovered an extraordinarily tiny galaxy that has been developing stars at an extremely fast rate given its dimensions. This tiny galaxy is one of the tiniest ever discovered at this distance, just after the initial explosion of the universe, and has the potential to help astronomers better understand galaxies that existed millions of years ago. This galaxy is beyond the capability of all telescopes except the James Webb, and the first observations of this distant galaxy are truly impressive, said Patrick Kelly, lead author of this study. Although the galaxy is about 1/1,000,000th the volume of the Milky Way, it is amazing that it continues to form the same number of stars each year. It's a fascinating phenomenon. If you're wondering how the James Webb Telescope can observe such minute details in a field wide enough to capture the entire galaxy, don't hesitate. The field of view of the legendary James Webb Telescope is wide enough to capture the entire galaxy cluster at once. This is mainly due to a phenomenon called gravitational lensing. Gravitational lensing uses lenses that bend and magnify the light from the mass present in the galaxy or galaxy cluster. Gravitational lensing has played a crucial role in making this small galaxy appear 20 times brighter than it really is. In fact, this may be the first time we have had the opportunity to observe such a distant part of the universe, almost to the very moment of the Big Bang. The James Webb Telescope with its exceptional ability to track galaxies, has made this task easier than ever before. Until now, we have only two space observatories capable of creating deep field images that allows us to see the universe in unprecedented detail: Hubble and James Webb. Hubble operates in the visible light range, while Webb focuses on the infrared. Although both capture images of distant galaxies in dimly lit areas of the sky, the Webb images are sharper because of their infrared. When we compare the deep field captured by each of these telescopes, we can appreciate their remarkable differences. The Webb images have their own distinctive look compared to those from Hubble. This is most evident in the appearance of the stars, with their distinctive 8-pointed diffraction peaks. These peaks are unique features of the Webb images because of the shape of its mirror. Webb's ability to observe objects in the infrared gives it a significant advantage over other space telescopes, including its predecessor, Hubble. Many objects that remained hidden or inconspicuous in Hubble's deep field images are now being revealed, literally, by Webb. If things turned out this way, 2023 is likely to be full of discoveries that will change our understanding of the cosmos, but who can predict with certainty what is to come? Thank you very much for watching the video. Remember to like and subscribe, and we'll see you in the next one.